All right, in this video, we're looking to simplify this complicated rational expression, right? And it has rational exponents as well as being a complicated fraction to begin with. So what we want to do in this case is try to look for some way to sort of cancel, right? And you might think of this x squared plus 9 here and say, well, hey, there's a bunch of x squared plus 9s above as well. Well, those x squared plus 9s, though, cannot be canceled at the moment. It'd be nice if we could do something like this, right? But we can't. And the reason why is because you can only cancel if things are expressed as a product in both the numerator and the denominator. So, this term, for example, could be canceled with x squared plus 9 in the numerator if this wasn't a difference or a sum. But it is a difference or a sum. In this case, it's a difference. And that means that we need to first factor the numerator so we can cancel the way we'd like to. So that means we're kind of stuck trying to factor that numerator. And the question is, how do we do that? Well, first thing you want to do if you're trying to factor is to what? Look at your two terms and say, is there anything common between the two terms? It certainly seems like x squared plus 9 is common, but the question is, what power would we take out with that, right? So for example, if it was x squared and the other one was x, we'd take out x, right? So what do we do in this case, right? Well, let me show you a quick example here to help us figure this out. What if I had y squared minus x squared times y? What would be your greatest common factor then? Well, we might be able to take out a y then, right? Leaving just y minus x squared. That would be a perfectly legitimate factoring, right? And the reason why we took out y as opposed to y squared is because this y was only to the 1 power, and both terms could not afford to give up a y squared. The last term could only give up 1y. So this is exactly how we're going to tackle the rational expression over here. We're going to say basically the smallest power between these two terms that have x squared plus 9 in them is negative 1/2, right? Because negative 1/2 is smaller than positive 1/2. And if that's true, then what we need to do is to take out the x squared plus 9 to the negative 1/2 power, just like we had to take out the y to the 1 power as opposed to the y squared over here. All right, so let's go ahead and do that. Let's write it out as if we're going to take out the x squared plus 9 to the negative 1/2 power. But then the question remains, how exactly does that factor out? Well, let's think about factoring for a moment. It's actually division, really, right? If you think about this, if I had my GCF of y here, then I would have taken out y from both pieces. And when you divide y here by y, that disappears. That's why the x squared doesn't have a y. And when you divide y squared by y, we cancel out the square and just have a y. That's why we only have a y in the front of that binomial, right? All right, so the same logic's going to apply here. We need to divide these two terms by our GCF. So let's divide the first term here by our GCF. Let's do it off to the side. So I'm going to say x squared plus 9 to the 1/2 power. And I'm going to divide that by x squared plus 9 to the negative 1/2 power. And what's going to happen is we're going to say, hey, both of these terms have the same base. They're both x squared plus 9. And the rule is when dividing two terms with the same base, you subtract their exponents. So you're going to do 1/2 minus a negative 1/2. Well, what happens here? When you have a negative negative, it becomes a positive. So we'll end up having x squared plus 9, and 1/2 plus 1/2 will end up giving you 1. So that means inside of here, the factor will just be x squared plus 9 to the 1 power. And that's what happens when you take out the x squared plus 9 to the negative 1/2 power. All right, now the second term is easier because we took this piece out, it goes away, and we just have x squared, right? Okay, from there, the denominator remains the same. We'll have x squared plus 9. Okay, from here, we'll go ahead and clean up the inside of the parentheses. So we'll have x squared plus 9 to the negative 1/2 power. Then inside the parenthesis, since it's just to the 1 power here, we're going to say x squared plus 9 minus x squared. Notice we don't have to keep that parenthesis because the exponent is only 1 there. All right, then divide by the x squared plus 9. Okay, well what's nice about that is the x squared here will cancel with the negative x squared, and you'll just have 9 there times the x squared plus 9 to the 1/2 power. So I'm going to write it as 9 times x squared plus 9 to the negative 1/2 power, all divided by the x squared plus 9. All right, now we have a common base here in the denominator and the numerator. we can take the smaller exponent down to the bottom. So in other words, the term that has a smaller exponent can be moved to the bottom to join the other one that has the larger exponent. The reason why we want to do that is because then we can combine them and we'll make sure the exponent ends up being positive at the bottom of the fraction. So we'll have 9 left in the numerator, and then we'll have x squared plus 9 to the first power times x squared plus 9 to the positive 1/2 power, because remember, when you bring it down across that fraction bar, you change the sign of the exponent. And then finally, you're going to multiply two terms with the same base, so you keep the base and add the exponent, and you're going to end up having 9 over x squared plus 9 to the 1 plus 1/2 power, and that ultimately is going to be 9 over x squared plus 9 to the 3/2 power.